test. Hello, hello. Testing mic. Hello, hello, mic test. Hello, everyone. Good afternoon. Hello, good afternoon, everyone. Can you hear me now? Hello, can you hear me now? Can you hear me, guys? Hello, guys, can you hear me? Alice? Buado? Vicente? Alvarez? Gonzalez? Banikid? Beatrice? Is Beatrice present? Orbi present. Nugid? Aquino?
Present po.
Caparas?
Aquino po.
Palaganas?
Sir, present po.
Verdiflor? Verdiflor? De La Piña? Almeida?
Present po, birthday floor, sir.
Almeida? Almeida, absent? Orbi? Sino to si Floyd? Floyd, what is your family name? Floyd? Particle, and remember that it doesn't matter no anong size niya, right? So now we are talking of particle moving along a straight line. So if particle is moving along a straight line, we call the motion as rectilinear motion. Okay? Then position coordinate of a particle is defined by positive or negative distance of particle from a fixed origin on the line. By the way, class, can you see the cursor moving?
Yes po, sir.
Okay.
Yes, sir.
Okay. That's
Yes
good.
po.
Alright, so assuming that the particle is starting at this point, so at t equal to 0, so it means that the particle is not yet moving. And when the particle is moving at t equal to, say, t1, so the position now of the particle is at this point, and it travels a distance that is equal to x. By the way, the distance from this point to this point is equal to 1 meter. Assumption natin. Alright, so ang gap niya dito is 1 meter. Okay? Now, we can also say that the particle can go to the left. So, on the first one, yung figure dito sa taas, if the particle is moving to the right, so we consider the distance to be positive. Okay? Then, if the particle is moving from the origin going to the left, so that is negative. Alright, so we call this distance as x prime and we call this point as p prime. Now, the motion of particle is known if the position coordinate of particle is known. So that is the condition, class. Malalaman natin kung saan siya pupunta, positive or negative siya, if we know its position coordinate. That is at every value of time. And motion of particle may be expressed in the form of a function. So we can have this function x as a function of t. So x here is the distance traveled by a particle, alright, and it's traveling with respect to time. Okay, so we have, for example, the motion of particle is given as a function of time. X as a function of time equal to 6t squared minus t cubed. Okay, so we can graph this function x as the distance traveled by the particle, and in one direction, I mean coordinate going upward, for example, and the time is going to the right or going to the left. So we can graph here the x versus time, as you can see in this picture here on the left side. Okay? Is it clear, class? So, ang ibig sabihin nito na kung i-graph mo itong function na to, x a function of time, ito yung makikita natin na graph. Okay? Particle which occupies position P at a time t, and p prime at t plus delta t, so shown in this picture. Alright, so this is the original position of the particle, point O. And the particle is moving to the right. Okay, so moving to the right at time equal to t. So the particle moves a distance or covered a distance that is equal to x at this point, point P. Can you please turn off your or mute your microphone? Just turn it on if you want to interrupt me or if you have some question. Okay? So, if the particle moves farther from this point P to the next point P prime, so there's a change of the distance, we call it delta x. Alright? And now it travels a duration of t plus delta t. So, ang time na nag-travel yung particle or nag-move ang particle from the origin or from this initial position to this point, that is equal to t. And now if it moves farther with a distance delta x, so there's a corresponding delta t that is spent by the particle to move from this point to this point. Alright? Do you have any question, class? Now, we will determine the average velocity of the particle. So to find the average velocity of the particle, so we have this formula that this is equivalent to the ratio of the change of the position with respect to time. Okay? Or the instantaneous velocity of the particle, we can call this as v, small v, equal to the limit of the ratio of the change of the position with respect to time as delta t approaches to 0. Okay? Question? You can interrupt me, class, anytime if you want to say something. Now we have here the possible sign of our velocity of the particle. So on the first picture here, as p moves to the right, then we can say that the instantaneous velocity v is greater than 0 or positive. Right? And if it moves from the certain position p, it moves to the left, then we have the instantaneous velocity less than 0 or negative. So the instantaneous velocity may be positive or negative, and the magnitude of velocity is referred to as particle speed or particle speed. Alright? Now from the definition of derivative, so ito yung definitions of derivative, class, from our differential calculus. I hope you still remember this. So we have the instantaneous velocity equal to the limit of delta x over delta t as delta t approaches to 0. And we know that in our differential calculus, if you have this limit of the function, ratio of this delta x and delta t as delta t approaches to 0, so in differential calculus, this is equivalent to the derivative of x with respect to time. Alright? The velocity at any time t, so this is just the derivative. You just take the derivative of this function, which is equal to 6t squared minus t cubed. So derivative of dx over derivative of the function x with respect to time equal to, so using your skills or knowledge in differential calculus, so this is just 12t minus 3t squared. Alright? Any question? Okay, so now if you graph this function, now we have a new function, that is velocity function of time, that is given as 12t minus 3t squared. So if you graph the velocity function, ito yung makikita natin, class. Alright? So at t equal to 0, so what will happen? We have here the velocity as a function of time. Alright? This is our time. So as t equal to 0, then we have here the velocity equal to 0. When v is equal to 2 seconds, for example, here. So substitute 2 in this equation. So 12 times 2, 24, minus 3 times 2 squared. So we have 12. So that's why we have here 12 at this point. Okay? When t equal to 4, so 12 times 4, that is 48, minus 3 times 4 times 16, 48 also. So 48 minus 48 is equal to 0. So that's why the point is at this point. Alright? And when t equal to 6, so substitute t equal to 6 here, then you have the velocity equal to minus 36. So that's why we have this graph of the velocity. Okay? Question? So consider the particle with a velocity v at t equal to t. Alright? So we have this illustration. So let's consider a particle with a velocity v at time t and v prime at t plus delta t. It means that there is a change of velocity class. Perhaps from this point, as the particle moves, ito yung velocity niya, mahina lang. Okay, when you speak of velocity, that is the change of the distance traveled with respect to time, right? Then as this is at t, no? At this time t. Now at time t plus delta t, meaning time goes by, so the velocity now increases. So we have the velocity of the particle increases, v plus delta v. So we have what we call the acceleration. So when we speak of acceleration, that is the change of velocity with respect to time. So nakita natin dito sa graph na to. So unang-una, yung movement ng particle is slow. That's why you can see the arrow, a small arrow, and you can see here a bigger arrow that indicates na nag-increase yung velocity niya. So there's a change in velocity. So we have the initial velocity, the first time that the particle moves with a velocity v. Now as time goes by, there's an increase of the velocity, we call it delta v. Okay, so now if the acceleration is what we call the change of the velocity with respect to time, and this is defined as the limit of the change of the velocity with respect to time as delta t approaches to 0. So ito yung another concept that we need to understand, saan to nanggaling, kailan to gagamitin, o paano to gamitin. Okay? So the instantaneous acceleration, ang tawag nito class sa instantaneous acceleration, meaning that is the acceleration at any time t. So the instantaneous acceleration may be positive, no? Or it can be negative. So kailan siya magiging positive? So positive, increasing positive velocity. So positive siya, increasing positive velocity. So ito yung illustration class. Okay? So nakita natin dito, initially maliit lang yung arrow natin, maikli, tapos next mahaba. No, this is just to make the illustration clearer to you kung ano yung ibig sabihin na nag-increasing siya. So this figure illustrates that the velocity is increasing. Okay? So in this situation class, if the velocity is increasing, it is going to the right. So we have here the acceleration that is positive. Okay? Are you following?
Yes po.
Okay, very good.
Yes po, sir.
Okay, next. So look at the next picture. Kanina ito yung diniscuss natin. Alright? So now, pangalawang concept. So look at this. So I said a while ago that it can positive, increasing positive velocity, or this can be a decreasing negative velocity. That is still considered positive. Do you understand this? So positive siya class, dalawang scenario. Ang unang scenario, ito yon, represented by this illustration. Okay? Unang-una, small lang tong, maikli lang tong arrow dito. Tapos dito, mahaba. So makita natin dito sa illustration na to na ang velocity is increasing. Do you understand this? And it goes to the right. So we have the positive acceleration. So positive. So ang scenario is positive siya, increasing positive velocity. So ito yung example ng increasing positive velocity. Now the other scenario is something like this. Positive pa rin siya, consider positive if it's decreasing negative velocity. You get it? So una-una dito galing yan class, okay? The particle moves to the left. Alright? So nakita natin na mabilis siya, no? Mabilis. So represented by mahaba na arrow. Okay? And then next scenario is that umikli na yung arrow. Ibig sabihin, the velocity is decreasing. Alright? You got it? So from illustration, the velocity is decreasing. So it means that the acceleration is positive. That's why you have here A is greater than 0, meaning the acceleration is positive. Okay class, so that's the dalawang scenario kailan siya maging positive. Okay? Even if the particle moves to the right or to the left, acceleration could be positive. So yun yung main concept. Next scenario is something like this. So the instantaneous acceleration may be negative. Okay? So another scenario is pwede rin siyang mag-negative. So kailan niya mangyayari? So tulad nito class, if you look at this illustration, okay? So mahaba tong arrow na to, it means that yung velocity mabilis. Okay? Then sa next position niya, umikli na yung arrow. So ibig sabihin humina. Okay, humina siya class. Ibig sabihin the change of velocity is decreasing. Right? So we have a negative. This is the negative, decreasing positive velocity. Positive ang velocity pero decreasing siya. That's why this is negative. Okay? And this is represented by this. A is less than 0, meaning the acceleration is negative. You got it, class? You got it? Are you following?
Opo.
Listen carefully ha, kasi
Opo, sir.
this is a very important concept. Dapat maintindihan nyo to. Kasi yung mga problems natin later on needs this concept. Okay, so next. Another possibility, kailan to siya magiging negative ang acceleration is this scenario. So tingnan tong next scenario class. Okay, so now the direction of the particle is going to the left. So initially, kita natin na ang velocity is mahina lang. Okay? Mahina. Going to the left. Alam natin ang particle going to the left, that is negative, right? Velocity negative. And then, it's increasing. Increasing siya, but going to the left. So, ibig sabihin, ang acceleration natin nito is negative. Or, A is less than 0. So, ito yung mga scenario class. Kailan magiging positive or negative ang acceleration. So, do you have any?
Yes po.
Sa calculus natin. Or as what we had discussed a while ago. Okay, so we have here acceleration as defined a while ago. That is the limit of the change of the velocity with respect to time. Then the delta t as approaches to 0. By the way, class, can you see the pencil that I'm using?
Hindi po, sir.
Okay.
Hindi po, sir.
Sorry. So I need to use the cursor. Alright. So from the definition, from our calculus, and we have reviewed a while ago, so the acceleration is the limit of the change of the velocity with respect to time. So alam natin na yung velocity, yung acceleration is the derivative of the velocity, right? Kasi ito siya, ibig sabihin nito derivative of velocity with respect to time. Alright? And alam din natin yung velocity is the derivative of the position or the distance traveled by the particle with respect to time. So in other words, yung acceleration natin, class, is just the second derivative of, kung ang x represents the position or the distance traveled by a particle, so yung acceleration natin is just the derivative or the second derivative of that position or x. So that's why we have here acceleration is the second derivative of x with respect to t. So parang dalawang bisis natin nag-derivative. So you are given x as a function of time. So for example, you have here ang x natin kanina is 60 squared, right? 60 squared. Tapos when we take the derivative, that is 12t. Then kanina sa x natin, ito yung t cube. So take the derivative of t cube, we have 3t squared. Okay? So we took the derivative of x as a function of time. Now we take the derivative again. Alright? So dalawang beses natin ginawa yung pag-take ng derivative. So that's why here we have velocity 12t. You take the derivative of this, that is 12, right? And then we have 3t squared. You take the derivative of 3t squared equal to 60. Okay? So now this 12 minus 60, ito yung acceleration, class. Okay? Let's continue. Okay, so here, if you graph the acceleration, ito yung makikita natin. So we have here acceleration A, which is the derivative of the velocity with respect to time, and that is equivalent to 12 minus 60. So when you graph this A equal to 12 minus 60, ito yung makikita natin na graph, class. Okay? So at t equal to 0, so kung 0 ang t, so 6 times 0, 0. So 12 na lang matira. So therefore acceleration is, we already have 12. When t equal to 2, so 6 times 2, 12. So 12 minus 12, 0. So that's why the acceleration here is 0 at this point. When t is equal to 4 seconds, so we're using the time as in seconds. So when t is equal to 4, so 6 times 4, 24. So 12 minus 24, that is minus 12. Okay? And so on. No, when t is equal to 6, we have t equal to, acceleration equal to minus 24. So we have this graph of the acceleration. Now, let's consider the particle with motion given by this equation. Okay? So, when you graph this as shown a while ago, no, in the previous slides, so ito yung graph niya, class. This is the graph of the function of the movement of the particle. So given as x equal to 60 squared minus t cubed. Okay? Now when you graph this, ito yung itsura ng movement of the particle. Now if you find the velocity, okay, so the velocity as discussed a while ago. So, derivative of this, 12t. Derivative of this, 3t squared. So, when you graph the velocity with respect to time, so, we have here the velocity with respect to time. So, ito yung itsura niya, no, as discussed a while ago. Now, when you take the derivative of this velocity, as discussed a while ago, so ito yung mangyari. We have acceleration equal to 12 minus 60 t. 12 minus 6 times t. And this is the corresponding graph. Okay? So, ito yung how to graph this one. You know, at t equal to 0, if you consider this one, you have x equal to 0. Okay? And so on. At t equal to, ibig sabihin, class, ito yung mga values na substitute natin sa tatlong equations na to. Tapos, graph natin siya. Alright? Just to show you how to do this graph. Any question? Are you listening? Okay, again, sample problem. The motion of particle is defined by the relation x equal to 1/3 t cubed minus 36t, where x is expressed in feet and t in seconds. Draw the following, no? So for A, you have to draw the x versus time. And B, x is the position or the distance covered or traveled by the particle, and B is velocity versus time, and C is A, or the acceleration versus time. So you need to draw or graph the following curves. Okay, so please practice that na look at the examples and try to do it yourselves. And determine when the velocity is 0. Then letter E, the interval where the particle is moving to the right. And F, the total distance traveled by the particle when t equal to 6 seconds. Okay, can you manage this, class? So, gagawin ninyo sa E and B, A, B, C. Pareho lang sa examples natin. Just look at the example and follow the procedures. Then, after that, determine when the velocity is 0. Okay, so you can see that from the graph. So, when the velocity is 0. Or from the equation, you can see that. Then, the interval where the particle is moving to the right. So, you represent the interval, class, your answer in terms of close an open interval. Pwede ninyong gamitin yung number line. Okay? Or the way you represent the interval as we have learned from our calculus. So that is for letter A. Then for F, total distance traveled when t is equal to 6 seconds. So you just calculate this using the equation. So for particle in uniform rectilinear motion, the acceleration is 0. So remember that concept, class. So for a particle in uniform rectilinear motion, the acceleration is 0 and the velocity is constant. So if the velocity, class, is constant, ibig sabihin walang pagbabago sa velocity, then the acceleration is equal to 0. Then we have this from the equation. A while ago we have remember we have V. So ang gagawin natin to, class, is to find out what is the distance x. So let's calculate the distance x. So to get the distance traveled by the particle, so gamitin natin yung formula kanina sa velocity. Alright? So we know that velocity is just the derivative of x with respect to time. And take note, as mentioned here in this concept, for the velocity that is constant, okay, velocity constant, acceleration is 0. So from here, what we're going to do, we have to multiply both sides by dt, or you simply cross multiply this dt here. So we have dx equal to v dt. Alright, v dt. Okay, so we have here dx equal to v dt. Now if we integrate both sides, so integrate natin both sides. Alright, so we have this integral sign on both sides. Okay, here. So for x, ang limit natin, class, for x is from x equal to 0, meaning this is the position of the particle before the particle moves, or the initial position of the particle. Alright, x equal to 0. Okay, and the upper limit, so that is the final destination or final point where the particle stop moving. So we call it x. Then in terms of velocity, we have, okay, so t equal to 0, ang position ng particle is at x equal to x0. Then the final position at x, this is the time. No, we don't know what is the time there spent by the particle to move this distance x. So we are generalizing it. So integrating, so integral of dx. So we know that integral of dx is x. Then substitute the upper and the lower limit. So we have x, the upper limit minus the lower limit, equal to, so integral of v dt. So v is a constant, ipalabas natin yung constant, we are just integrating the dt. So we know that the integral of dt is simply t, right? Then you substitute the limit 0 to t. So final, initial. So final minus initial. So t minus 0. So t minus 0, that is still t, right? Then t minus v, t times v. So we have vt. So therefore we have now the equation for the distance traveled by a particle, a uniform in our uniform rectilinear motion. So x equal to x sub 0 plus vt. Okay, so remember this formula, class. Alright. So we have here a sample problem. Okay, so sample problem: an automobile is driven along a straight line at 30 miles per hour. So ano yung 30 miles per hour, class? What is the 30 miles per hour? So ano yun? So, anong given na yan? So that is the initial or final velocity? Or a constant velocity?
Constant velocity, sir.
Come again?
Constant velocity po.
Alright, so we have the constant velocity of 30 miles per hour for 12 minutes. So ano yung... So we are given the time, no? For 12 minutes. Constant siya. Constant yung movement ng automobile for 12 minutes. Then, at 40 miles per hour. So, nag-change yung velocity, no? We have initial velocity that is 30 miles per hour for 12 minutes, and then 40 miles per hour for 20 minutes. Alright? And finally, the velocity, the next velocity is 50 miles per hour for 8 minutes. Now the problem is, what is its average speed over this interval? Okay, so that's for A. And then, how fast must the automobile move in the last 8 minutes to obtain an average speed of 35 miles per hour? Okay, any idea on how to solve this? Okay, so sorry. So we just use the formula that we had derived. Okay. Sorry class, we have no time, no? I have another class after your class. So practicean nyo lang class, and then I will ask you the answer for this problem next meeting. Okay?
Okay po, sir.
And then please log on again to our BBL. Doon ako mag-check attendance. Okay? Balik kayo doon.
Okay po.
Okay.
Okay po.
Thank you. Thank you very much. Have a nice day. Next time, ganun din gagawin natin class, ha? Use Zoom. Okay?
Okay po, sir. Thank
Okay.
you po, sir. Thank
Okay.
Okay po, sir. Thank you.
Okay. Thank you very much.
Sir po. Tawagin niyo ba po si Lisa?
Sige lang, titingnan ko lang yung mga names niya. Type your names lang once na nasa loob na kayo.
Sir po. Tawagin niyo ba po si Lisa?
Sige lang, titingnan ko lang yung mga names niya. Type your names lang once na nasa loob na kayo. You can leave na pag nakatype na kayo.
Okay po, sir. Thank you po. See you
Okay.
next meeting.
Okay, see you. So, study ha. Try to solve the problem. Okay, you're welcome.
Salamat po, sir.
Okay, you're welcome. Ingat kayo ha. Keep safe always.
Thank you, sir. Next po.
Sige. Ingat.
Paano magta-type po. Thank you, sir.
Okay, you're welcome. Ingat kayo.
Okay po, sir.
Just pag may discrepancies, i-upload ko yung video class. May mga discrepancies doon sa attendance. Just comment, leave a comment on the channel.
Sir, nakapag-type na po.
Okay, okay. Ingat.
Pwede na po mag-leave sir.
Yes, pwede na. Pwede na mag-leave.
Sas. Nag-PM ako sa'yo, pa-check na. Ay, sige. May mga tawag sa kasi.